So, number 2. It says my model is 1.5 inches. What might be an easier way for me to write this instead of 1 and then the fraction 1/2? Let's do 1.5. So 1.5 inches. That's my model. We're going to multiply that to, what does this fraction need to look like? 8 inches over 1 inch. Remember, that first value is telling me about the model, and so it goes on the bottom. The second value is telling me about the full size, and so it goes on the top. That's why 8 inches is in my numerator, and I don't know why I wrote 1.5 centimeters. It's 1.5 inches. There we go. We take that 1.5 inches, we multiply it to the 8 inches. What is 1.5 times 8? 12. So I have 12, and then I've got the unit of inches twice. Down in my denominator, I had 1 inch. What happens at this point? Yeah, one of my inches cancels because I only have 1 in the bottom, so only 1 in the top cancels out. And then I'm going to divide these two numbers. 12 divided by 1 just gives me 12. And I still have the unit of inches left over because there was still an inches up top. All right, number 3, the model is 2.5 centimeters. So I have 2.5 cm multiplied by, what is this fraction going to look like? I think somebody might have said something, but I didn't hear it. 1/10. What's the unit on the 1? Kilometers. And the unit on the 10? Centimeters. So we take 2.5 and we multiply it to just the numerator, just to the 1. So I get 2.5. I'm going to run out of room if I do it right there. 2.5. I still have centimeters and kilometers here. Over 10 centimeters. What happens next? Centimeters cancels out. So then I do 2.5 divided by 10. What is 2.5 divided by 10? 0.25 kilometers. Number 4, our model is 15 inches. So I need to do 15 inches times what? 2 over 5. We have miles with the 2. We have inches with the 5. So now we take the 15, only gets multiplied to the top. What is 15 times 2? So I have 30, I have inches, and I have miles up here. Over 5 inches. My inches cancel out. So how many miles is the full-size object? 6 miles. And then the very last one. We have the model is 33 centimeters. So I have 33 cm times what fraction? 75 over 15. 75 is kilometers. 15 is centimeters. I take the 33 and I multiply it to the 75, and that gives me what? 2,475 centimeters and kilometers up there over 15 centimeters. My centimeters top and bottom cancel out. Now I have to divide 2475 by 15. 165 units. Kilometers. Beautiful work. Very nice job. All right. We are going to be in your extra notes today. We're going to see how far we can get. If we don't finish up what we need to in the extra notes today, we'll finish it up tomorrow. We will also be in your book tomorrow for sure. We were on page 6 on Friday. We talked about different types of similarities. And we did part A and B on number 1, where we were determining whether or not those triangles were similar, and if they were, using which one of those postulates, and writing a triangle similarity statement. So we're ready for part C. What is there in this picture that I'm allowed to mark, even though it's not already given? Vertical angles. So angle E on both sides. We've got our vertical angles marked as congruent. Can I mark anything else? Do we know about anything being parallel? No. There's nothing else I'm allowed to mark. They don't have any shared sides. I don't have a reflexive property happening here. We just have those vertical angles. That's all I've got. Are we going to be able to use angle-angle similarity on this one? No. I have one angle in each triangle, but I don't have a second pair of angles, so I'm not going to be able to use angle-angle. Will I be able to use side, side, side? Why not? We only have 2 sides on each triangle, not all 3. So we're going to have to try for side, angle, side. For side, angle, side, we need a pair of congruent angles. Do we have that? Yes. And then we have to show that the 2 sides on either side of that angle, so like 45 and 30, that's on either side of this angle. Or I've got 9 and 6, that's on either side of this angle. I have to show that those sides are proportional to each other. So I'm going to have to set up some fractions and check to see if it comes out to be the same. All right, so I got to pick a number to start with. I'm going to start with 30. So we are checking for proportional sides. Which side do you think corresponds to the 30? 6? Okay. Is that equal to? So if 30 corresponds to 6, what should my other fraction look like? I'm sorry, what'd you say? 45 over 9. All right, so let's see. What is 30 divided by 6? 5. What is 45 divided by 9? 5. Did those come out to be the same? Yes, they did. So my sides are proportional. Before we write anything else down, what should you do when you're checking on side, angle, side if you do this and they don't come out to be proportional? Switch them around. Try it the other way. Because sometimes it's hard to tell if you have those corresponding pieces lined up correctly. So if we had done 30 over 9 equals 45 over 6, that wasn't going to come out to be proportional. You can check it on your calculator later if you want. But then when I flip those denominators, when I try it the other way, it did come out to be proportional. So what's our reason for similarity? Side, angle, side. Is this correct? No. What am I missing? The squiggle. The squiggle is super important. Without the squiggle, you're saying they're congruent. You're saying that they're the same size. With the squiggle, it means they're similar. It means they're the same shape, but not the same size. All right, now we need to write our similarity statement. So triangle something is similar to triangle something else. The way we name the first triangle doesn't matter what order you put the letters in. What do you guys want to name the first triangle? FGE is what I heard, so let's go with it. Any order for that first triangle. For the second triangle, we have to make sure that we are matching up the corresponding congruent angles and the proportional sides. So this starts with FG. How big was side FG? Did we have a size for FG? So that would have to match up with the other side over here that we don't have information about. What would that side be? RS. And we'll check in just a minute to make sure that we have those letters in the right order. What would have to come at the end? E has to come at the end. We know that E is congruent to E because those are my vertical angles. All right, now checking that I have these in the right order. Let's check our second two letters, GE. Here's GE. How big was that one? 30. And that was proportional to which one on the other triangle? ES. So the second two letters have to be ES. There's my ES. All right. Part D, last one on number 1. Last one on this page. We have two different triangles in this picture. There's this little triangle, JQR. So I'm going to go around that with orange so that we can all see it clearly. And then I have a much larger triangle, JKL. You guys see both of those triangles? Is there anything that those two triangles have in common? Anything that they share completely? J. Angle J right down here. Angle Q is part of this side, so it's part of my orange triangle, but it has a linear pair to it on the blue triangle. So the only thing that they share completely, where they share all the parts of it, is angle J down here. This would be a shared angle. Just like a shared side, it is congruent to itself. That's my reflexive property. Are there any other angles that they share completely like J? No. So am I going to be able to use angle on this one? No. Will I be able to use side on this one? No, because there's a missing third side on both triangles. So I can't use side angle side. Or sorry, side. Could I try for side angle side? Yes. Okay. So if I'm going to use side angle side, I need the two sides on either side of my angle. So let's do the little triangle, the orange one here. How big is the bottom side on my orange triangle? 9. How big is the bottom side on my blue triangle? How big? Sorry, I heard lots of numbers. Not 39. 39 is just this much right here. 48. How'd you get 48? Add these two together. 9 plus 39. This side is 48. So the 9 and the 48 probably make a fraction together. So I'm going to set up my proportion and do 48 over 9. Is that equal to, now let's look at our other one. How big is this side, JQ, on my orange triangle? 11. How'd you guys get that? 66 minus 55. That gives us 11. How big is JK? 66. So 66 over 11. I think I have things matched up with their corresponding sides. If this doesn't come out to be equal, we'll flip those denominators. We'll match them up differently and try again. What is 48 over 9? 5.3 repeating. What's 66 divided by 11? 6. That didn't come out to be proportional. So let's switch our denominators and try again. So that would be 48 over 11. And 66 over 9. What is 48 over 11? I'm sorry, I didn't hear the decimals. 4.36. And 66 divided by 9? 7.3 repeating. Did not come out to be equal. So what does that mean? These triangles are not similar. The sides are not proportional. All right, let's flip the page. So what would be page 7 if we had page numbers? But I forgot to put the page numbers on. I've got 4 different triangles here. What do the directions want me to do? So there's one typo in this directions. Can anybody find what the typo is? The word congruent. What have we been talking about so far? Similar. Let's mark out congruent and write in similar. What are the 3 postulates that we have that we could use to show 2 triangles are similar? We could use side, angle, side. Similarity has to have the squiggle. Side, side, side with the squiggle. Side, side, side similarity. And angle, angle similarity. All right, so let's look at these triangles. We're going to compare 2 at a time. Part A, we need to compare triangle MNL. That's this first one here on the left. To triangle VUW. That's the farthest one to the right. So we're going to compare the biggest and the smallest ones. What do you notice about those 2 triangles? Anything that they have in common? 70. They both have a 70-degree angle and a 50-degree angle. Is that enough to say these 2 triangles are similar? Yes, using which one? Using angle, angle similarity. Could we use side, side, side similarity? Do we have enough information to use side, side, side? No, why not? Yeah, I don't know how big MN is. I have to have all 3 sides on both triangles. I also don't know how big VW is or UW. I don't have enough information to use anything except angle, angle here. All right, let's look at number 2, part B. Let's compare triangle MLN again with triangle SRT. So the third one in line right here. Could I use angle, angle again? Yes, what are the angles that they have that are shown to be the same? 60 and 50. We have a 60-degree angle on both triangles. And we have a 50-degree angle on both triangles. So I could use angle, angle similarity here. Could I use side, side, side similarity? I have all three sides here, but not on the other one. We don't know how big MN is, so I can't do side, side, side. Could I do side, angle, side? I think so. Let's look for an angle that they have in common, and then we have to know the two sides on either end of that angle. Should we use the 50 or 60 degree angle? 60 degree angle, because I have 12 and 18 on either side here. 60 degree angle here. That would match up with which two pieces? 6 and 9. So let's check to see if the sides are proportional. What should you do if you check the first time and it doesn't work? Switch the denominators, try it again. Let's start with 12. What do you think 12 corresponds to? 12 over 6, is that equal to, what would my other fraction have to be? 18 over 9. What is 12 over 6? 2. 18 over 9? 2. My sides are proportional. So we could use angle, angle, or we could use side, angle, side similarity. Part C. Triangle POQ. Well, POQ is this one right here. And triangle SRT, the one right next to it. Do we have angles in common? Nope. I got a 70 degree angle up here. I don't have anything marked there. I have 60 and 50. There's no 60 or 50. None of the angles are the same. Could I use side, side, side? Yes. So here's something that we can do so that we don't have to just keep guessing and checking when it's a side, side, side. When we're checking for side, 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 we have to match up the smallest sides from both triangles. We have to match up the biggest sides from both triangles. And then whatever our leftover side is. So let's do POQ first. What's the smallest side on POQ? 9. What's the smallest side on SRT? 6. So I would have to make a fraction with 9 and 6. Are the sides proportional? I can do 9 over 6 or 6 over 9. I think I'm going to write down 9 over 6 just because that's the way I circled them. Is that equal to? Now we have to do the same thing with the biggest. What's the biggest side on POQ? 13.5. And the biggest side on SRT? 9. So 13.5 over 9. And then what's my leftover ones? 12 and 8. So 12 over 8. I have to see if these come out to be equal. What is 9 divided by 6? 1.5. What about 13.5 over 9? 1.5 again. 12 over 8? 1.5. All of these came out to be the same. So my sides are proportional. That means we can show these two triangles congruent by side, side, side similarity. Could I use side, angle, side similarity? Do I have a corresponding congruent angle between these two triangles? No. Question. If we were so inclined, could we figure out how big angle S is? Because all the angles in a triangle add up to 180. So if I wanted to do a little extra work, more than just what's printed on here for me, we could find that angle. And if it's 70, then we could do this by side, angle, side also. But I don't know how big angle S is, and I want to move on to the next part. Let's look at triangles POQ and VUW. So POQ, this guy right here again, and VUW, this guy over here. Do we have anything in common? We have a 70-degree angle here. Do we have another angle that we know about? Like another pair of congruent angles? It looks like it's congruent. Do I know it's congruent? No. The only one that I know is congruent is that 70-degree angle. So can I use angle, angle here? I don't have enough given information. Can I use side, side, side here? Why not? I don't have all three sides on VUW. Could I do side, angle, side? No, why not? I need at least two sides on VUW if I'm going to do side, angle, side. And I only have the one. I only have this side here. So I can't prove these are similar. We only have one pair of corresponding angles and one pair of corresponding sides. And that's just not enough information. Does that mean that they're definitely not similar? Just means I don't have enough information. I can't prove it, so I can't say, yes, they're similar. They might be. I don't know. I can't prove it, though. So far, so good? All right, on number 3, we've got two parts, A and B. These triangles are similar. We have to write the similarity statement. We have to determine why they're similar. So on part A, is there anything I'm allowed to mark on part A that's not there already? Vertical angles. We can always mark our verticals. Is that enough for me to say these two triangles are congruent to each other? Yes, using which triangle postulate? AA. We've got our vertical angles that are congruent, and then I've got two 90-degree angles, one on each triangle. So the triangles, sorry, not congruent, triangles are similar. I keep screwing this up today, and I don't know why. Triangles are similar by angle-angle similarity. Now let's write the triangle similarity statement. Let's call the first one IHJ. We have to be careful how we name the second one. Angle I doesn't have any congruence markings on it at all. That would have to correspond to which angle on my other triangle? L. H has a right angle, which means it corresponds to K. And angle J was my vertical angle, so it is congruent to J. It corresponds to J. Fantastic. It says identify the similar triangles, then find the value of x. Where's x in the picture? JK. So I'm going to start a proportion. JK goes on top. JK is the last two letters in the way we named that second triangle, which means it has to correspond to which side on the other triangle? HJ. So JK over HJ, which would be x over 10. Now let's do our other proportion. What's the only other side that we know about on the little triangle? 4, which is KL Well, KL is the first two letters in the way we named that triangle, which means it has to correspond to what? HI. How big is HI? 8. So KL over HI, or 4 over 8. What do I need to do to get X all by itself? Multiply by 10. When we want to get rid of a fraction, it's always the bottom that we multiply by. And now I want you to look really closely on the right-hand side of the equal sign. Do I have any variables? Nope. It's just numbers and operations. We can grab our calculator and just type it in right here. 4 divided by 8 times 10. Five. Perfect. Let's see how far we can get on part B. I don't know if we'll finish it, but we're going to get as far as we can. Is there anything I'm allowed to mark just because? Vertical angles. So angle L on one side is congruent to angle L on the other side. There's something else I notice. JK has this little arrowhead on it. NM has the same. You're right, it's parallel. When I see two triangles and I got these parallel lines like this, what shape should I draw? A Z. So let's draw our Z shape. What does the Z shape help us find? Not corresponding angles. They're going to be congruent. They're alternate interior angles. Alternate interior angles. So angle J is congruent to what? M. And I just realized, let me pause here for a second for a little language stuff. We call them corresponding angles when they're similar, but when I'm talking parallel lines, they're not corresponding because that has a different meaning when I'm talking about my parallel lines. And we'll talk more about that like tomorrow and the next day. We'll get a refresher on what corresponding angles look like there. But when we're talking about a similarity statement, yes, J and M are going to correspond to each other because they're congruent. It's not the same thing as corresponding angles. I realize that that's a little confusing. Do I need to go any further to say that these two triangles are similar? What could I use to say they're similar by? Angle, angle. So the triangles are similar by angle, angle similarity. So let's name them. What do you want to call the first triangle? JKL. I'm just going with the first thing I heard. There's no wrong way to name that first triangle unless you pick out letters that aren't part of it. Angle J is congruent to what other angle? M, so I have to start with M. K doesn't have any congruence markings on it, but I could have drawn my Z the other way. K has to match up with what? N. And L with itself, with L. Technically, it's the other side of L, but yes, letter-wise, it's the same thing there. All right, we're supposed to find X. Where's X? JL, right here. That's X plus 18. JL is first letter, last letter. So that would have to correspond to what on the other triangle? ML, first letter, last letter. So that would be this right here. So when I set up that proportion, I have X plus 18 over X minus 3. Big triangle, what other side do we know about? JK, 16. Well, JK is first two letters here. So that has to correspond to what? MN. You guys already told me that JK is 16. How big is MN? 4. Beautiful. I have X in two spots, top and bottom of my fraction. I can't cancel them out. We can't do anything as long as these are still fractions. I have to make them not fractions anymore. Yes, I can. Which denominator do you want to do that with first? We can choose either the 4 or the X minus 3. You want to do X minus 3 first? Sounds good. x minus 3. We're going to multiply on both sides. It's always the denominator that you multiply by. And that will always only distribute to our numerator. So the 16 is going to distribute to the x and to the 3. So I would have x plus 18 equals, well, that's going to be 16x minus 48 all over 4. What now? I didn't hear. What do we want to do? Do the same thing, but with the 4 now. So I'm going to multiply 4 to both sides. Got to scoot my work over, though. The 4 is going to distribute to both the x and the 18. So I have 4x plus what? 72 equals 16x minus 48. That's where we're going to pick up tomorrow, and we will finish solving this problem. The homework that you guys picked up in class on Friday is not due until Thursday this week, so not tomorrow, but day after tomorrow. If you need another copy of it, you can find that over here in this red paper organizer. It's always going to be the lowest down is the newest. So you can grab another copy of the homework here. Or if you want to do it in your book, it's spread out over 2 different sections in your book.